Hi, so welcome back to chapter number 7. So this will be the last chapter I'm going to cover in this free online admits class. Okay, so linear programming is a very interesting topic. Questions are not that difficult to answer. And if you see any questions in the exam, try not to skip any questions on linear programming. They're quite easy to do. Now, I will do a few problems here, then I will explain how you can solve a few problems, then you'll understand that it's not that difficult to solve problems in linear programming. Okay, so I'll copy down first linear programming, chapter number 7. So as I mentioned earlier, this will be the last chapter that I'm going to cover in this online free online advanced tuition. Okay, now there are not a lot of notes in this chapter, so I'm going to make it very brief and then take out directly to solve some questions. So just copy down section 7.1. It says linear programming model. Okay. So linear programming model. The word linear programming actually refers to optimizing, minimizing or maximizing a certain situation. Why we do that? Because we want to, for example, to reduce cost or to increase, to maximize production and so on. And then what is meant by model? The model here is actually a mathematical model. So we call it linear programming model. The model itself is actually an equation. The equation is just a mathematical model. So there are a few steps that you need to follow. So just copy down here. Steps to formulate. Okay, steps to formulate linear programming models. Okay. So what are the steps that we use in order to formulate? Formulate means to come up with the equation of the linear programming models. There are three steps. Step number one, what we do is we try to identify the decision variable. So we identify decision variables. Okay. For example, X and Y. Okay. So X and Y can be any variable that we want to maximize or minimize. So we want to make decision on this variable. So we call them decision variables. And then number two, what we do, the second step, we identify an objective function. Identify objective functions. Okay, example, objective function is k equal to 4x plus 2y. So k can be any number, any value. And because k can be changing, you'll find that this function can actually move along the graph. We move it in such a way that we want to optimize, we want to maximize or minimize certain parameters. So we call this the objective function. Number three, we identify what are known as constraints. Okay, so constraints in Bahasa we call this kekangan. We try to identify constraints. Example, x minus y is less than or equal to 10. Okay, so remember that whenever we talk about constraint, we always have this inequality, less than or equal to, greater than, and so on. So all these are constraints. So these are the basic three basic steps that you need to know in order to formulate linear programming models. The most important will be the constraints. So you must read the question carefully and try to think. Number one, you need to identify what are the decision variable within that question. And then we identify constraints. And then objective function usually is given to you, or sometimes you can formulate the objective function and depending on the problem. So I'm going to give you a few examples. So we're going to look at self-exercise 7.1. I'm taking direct to self-exercise 7.1. Okay. So we're going to do question number 1, question number 3, and question number 4. Okay, I will show you all step by step how to do it. Now let's take a look at question number 1 first. So question number 1, I've rewritten here separately so you can see this more clearly. Okay. So in question number 1, graphically illustrate. Now you're asked to draw a graph, graphically illustrate. It means show on a graph each of the following linear inequalities. So these are inequality. So these are also constraints, but here we just look at them as inequalities. So you're asked to illustrate. So in other words, you draw the graph and then you're asked to shade the area that satisfy this condition. So we will look at question number 1 part A first. Okay, so just copy down self-exercise 7.1 number 1 part A. Okay, so you're given 2y minus 3x is greater than or equal to 12. Okay, so let's see how to illustrate this graphically and show this on a graph. Show this on a graph paper. Now what we're going to do is we're going to draw a line, draw a straight line given by 2y minus 3x equal to 12. So we remove the inequality when we want to draw the line. We draw the line first. Okay. So in order to draw the line, you just need to know 2 points. So what we do here, we just find out what is the value of x when y is 0 and y when x is 0. Okay. So when x is equal to 0, 2y will be 2y minus 3, 0 will be 12. So this will give you y is equal to 12 divided by 2 will give you 6. So this will give you 1 point with coordinate 0 and 6. Okay, so we need one more point in order to draw a straight line. When y is equal to 0, okay, when y is equal to 0, 0 minus 3x is equal to 12. So negative 3x is equal to 12. So x will be equal to 12 divided by negative 3. This will give you negative 4. So you have one more point here, which is negative 4, 0. Okay. So using these 2 points, now we can draw the straight line. We draw the straight line first. Okay, here I'm going to show you on a graph paper. So remember the 2 points here, you have 0, 6, 4, and 0. So maybe I'll just show you how to draw. So we draw the axis first. Okay, draw the horizontal axis. So this will be a horizontal axis. Okay, make sure that you can label the point 0, 6 and negative 4, 0. So 0, 6 you have, we have 1, 2, 3, 4, 5. So I'm going to move this down a bit so we don't have enough space. And then on this side, negative 1, 2, 3, and 4. So it should be okay. So I'm going to label I'm going to label the vertical axis here. Okay, label this as 1, 2, 3, 4. I think it's better to label this as 2, 4, 6, 8. Yeah? So otherwise there may not be enough space on your graph. So we label this as 2, 4, 6, 8. Yeah? So this will be your y-axis. This will be your x-axis. 2, 4, 6, 8, 2, 4, 6, 8. Over here you got negative 2, 4, 6, 2, negative 4, negative 6, negative 8. And then here you have negative 2, negative 4. Okay, so we look at the first point. First point will be 0, 6. So 0, 0, 6, 0, 6 will be here. X will be 0, Y will be 6 will be here. Okay, and then the second point is negative 4, 0. Negative 4, 0 will be here. Okay, and then you can draw a straight line passing through these 2 points. Okay, use a ruler, draw a straight line passing through these 2 points. Okay. So after drawing the straight line, we are going to shade the region that satisfies this condition. So this is above 12, above 12. So above more than or greater than will refer to the region above the line. Okay, so we are going to shade this region. Okay, so that will be your answer. So all the region above the line will satisfy that equation. So if you want to confirm, so you don't have to do this in your exam, but if you want separately, yeah, you can just confirm. So you can test a point negative 4 and 4. So you can take one point here, negative 4 and 4. Okay, which lies in this region, just to confirm. So here, if you put this inside this equation, you will get 2x, x will be negative 2y, 2y will be 4. The equation is 2y minus 3x. So 2y minus 3x will be negative 4. So when you work it out, you will get 4 times 2, 8. 8 plus 12 will give you 20. So which is much more than 12. So this part will satisfy the equation given to you. And the equation says 2y minus 3x must be more than 12. When you calculate the value for a point in this region, you will get 20, which is more than 12. So this will be your answer, how you shade the diagram, how to shade the graph. Okay, so this is based on this equation. So I will show you one more example based on this equation, part C. So in part C, okay, in part C, you are given y plus 7x. Okay, in part C, y plus 7x minus 49 is less than or equal to 0. And you're asked to illustrate this graphically. So what we do here, we draw a line given by y plus 7x minus 49 equal to 0. Okay. So when x is equal to 0, we have y plus 7, 0 minus 49 is 0. Now straight away you'll get y equal to 49. So you get 1 point which is 0 and 49. Okay, so you don't have to simplify the equation first. Then straight away you can substitute the value x equal to 0. When y is equal to 0, we have 0 plus 7x, there, 7x minus 49 is equal to 0. So x will be equal to 49 over 7, which will give you 7. So immediately you will get one more point, which is 7, 0. Okay, so you got 2 points like this. So we can now draw the 2 points on the graph. 0, 49 and 7, 0. Okay, let me copy the graph paper again. Okay, so here, copy. No, let me copy a new graph paper. It was here. Okay, let me copy a new graph paper. Okay, so we have 2 points here, 0, 49 and 7, 0. Okay, so what we do here, we label the axis. You remember that here you have large number in the y-axis, smaller number on the x-axis. So you can label this as 10 up to 50 on the vertical axis. So if we are using the same scale, so we draw a vertical line here first. And then a horizontal. So on the vertical axis, you need up to 50. So you need, for example, here. So you have 1, 2, 3, 4, 5. So this can be your 0 point. So your horizontal line, horizontal axis will be along here. X-axis is here, y-axis is here. So you have 10, 20, 30, 40, and 50. Over here you got 10, 20, and 30. 10, 20, 30. Over here you got negative 10, negative 20, negative 30, and then here you got negative 10, negative 20. Okay. So the first point will be 0, 49. So 0, 49 will be somewhere here. This point will be 0, 49. Okay. And then the second point is 7, 0. 7 is 0 will be somewhere. Okay. So this point is 7, 0. And then 0, 49, 0, x is 0, y will be 49 this way. So what we're going to do is we're going to draw a straight line through the 2 points. So I will draw one line here first, then later I will correct this. Sorry. Okay, if you use a ruler, it's easier to draw one. One will pass through here. Okay, so this will be the equation of the line y plus 7x minus 49 equal to 0. But the question is less than, it says less than. Less than will be below the line, so you need to shade this part here. So everything on the left hand side will be below the line. So the region below the line, everywhere here, in fact, this whole region below the line will now satisfy this equation. Okay, so you need to be careful how to identify which area, whether it is below or above the line. So if the line is sloping to the right or left, anything above the line will be more than. Anything below the line will be less than. Okay, so this side will be less than. Okay, so that will be your answer. Now for question number 1 part C. Okay, so I'll try this again, see whether you can get the same graph. Now I'll take you to a slightly longer question, question number 3. So I'll copy this first, then we will read this very carefully here because this is a very long question. Okay, let me crop out this question alone. Okay, so this question is guiding you step by step how to do. So normally exam question, they won't guide you so nicely. So you need to figure out how to solve the problem. But in this question, you are asked to, you are given a few steps, A, B, and C, and that will guide you how to solve the question. Okay, so if you're ready, take a look at question number 3. Consider the situation below, then answer each of the following questions. So read the question very carefully. If you haven't done this, try this again later. The question says, Chin Tian wants to plant banana and papaya trees on a large plot of land of 80 hectares. So 80 hectare refer to the area, the size of the land. So it is 80 hectares. He hires 360 workers with a capital of at least 24,000. Okay, note the word at least. The amount of money he is putting in initially, you call that capital. Capital is at least 24,000. He uses X hectares of land to plant banana trees and Y hectares of land to plant papaya trees. Remember the variable X. Earlier I was saying that this becomes the variable. This is what are known as the decision variable. X and Y are the decision variable. So X referred to hectares of land, the size of the land used to plant banana trees, whereas Y referred to the size of the land used to plant papaya trees. Now every hectare planted with banana trees will be supervised by 3 workers. So each hectare requires 3 workers. That is for banana trees, whereas we need 6 workers supervise every hectare of papaya trees. The cost to maintain the banana trees is 800 ringgit per hectare, while to maintain the hectare of papaya trees is 300 ringgit. Question number A. Identify the constraints in the above problem. What are the constraints? Okay, so if you read your answer question carefully, you'll notice that the constraint, one of the constraint will be the land area, because he has only 80 hectares. Another constraint will be number of workers. Another constraint will be the cost. So the constraints are given by the figures here. When you see the numbers here, they are the constraint. So the first constraint will be area of land. Is constrained to 80 hectares. Okay. So that is given to you, and the area of land is 80 hectares. That becomes one constraint. Another constraint is number of workers. Okay, so number of workers is 360. Okay, there are 360 workers, and then the capital is RM 24,000. Capital is modal, how much you want to invest. So these are the constraints within that question we try to identify. And then part B says, form a mathematical model related to the above problem. A mathematical model. So we know that, so before we form the model, we need to identify what are X and Y. So X is the land area to plant banana trees. Land area for banana. Okay. And then Y is the land area for papaya. Land area for papaya. So remember X and Y are areas. So the first constraint will be the total area. X plus Y will be the total area. Okay. So the total area must be less than or equal to 80. Okay, so because 80 is the amount of area he has. That will be the first mathematical model and the first constraint or mathematical model. Now the second mathematical model is related to number of workers. So number of workers is 360. So remember that banana tree requires 3 workers per hectare, whereas papaya tree requires 6 workers per hectare. So it becomes 3x plus 6y must be less than or equal to 360. Okay, so that will become the second equation. Okay, so 3x plus 6y must be less than or equal to 360. Okay. So what is the third constraint? Third constraint is related to the cost. Now, the cost to maintain is 800 per hectare. The total capital is at least 24,000. So at least means more than or equal to. So the cost to maintain banana tree is 800 per hectare. So 800x, okay, plus 300y will be more than or equal to 24,000. So he needs a model of he needs investment capital of 24,000. Okay, so these are the three constraints and three equations. Now take a look at part C. What are you asked to do? You asked to represent each mathematical model graphically. Okay, you are asked to draw graph. So in part C, we need to do this one by one, because you have to draw a graph for each of the model. So x plus y is less than or equal to 80. Okay, so how are we going to represent this graphically? Same thing, what we do, we draw a line for x plus y is equal to 80. So when x is equal to 0, when x is equal to 0, y will be equal to 80, because you got 0 plus y. So this will give you the first point, which is 0 and 80. When y is equal to 0, okay, y is equal to 0, then your x will be equal to 80. This will give you the second point, which will be 80, 0. Okay. So I will sketch a simple graph here. So later you all can do this properly on a graph paper. So what I'm going to do is I'll draw the vertical axis. Then the horizontal axis over here. Okay, so I'm just going to label this in 10, 20, 40, 60, 80. So I'm going to label this as 20 because we have 80 there, so we need some space. So we have this will be 20, 40, 60, 80. 20, 40, 60, 80, 40, 60, 80. Here we have negative 20, negative 40, negative 60, negative 80, negative 20, negative 40, negative 40, negative 60, and so forth. So we have 2 points here, 0, 80, 0, 80 will be 1 point over there, and then 80, 0 will be here. So we draw a straight line from here to here. Okay, so you all can do this properly on a graph paper. So this will be the straight line for x plus y equal to 80, but you're asked to define the area less than 80. Yeah? So less than 80 will be all the area below this line. So you can just shade the line, area below this line. So this region will satisfy the equation x plus y less than or equal to 80. Okay? Because it is less, so you shade the region below the line. So this is this is one of the equation, x plus y less than 80. So how are we going to plot the second equation given by 3x plus 6y less than 600? So we just write down here 3x plus 6y is less than or equal to 360. Okay, so we draw the line. Draw the line given by 3x plus 6y equal to 360. Okay, so when x is 0, so we have 3, 0 plus 6y is 360. So y will be equal to 360 divided by 6 will give you 60. So this will give you the first point, x is 0, y is 60. Okay, so second point, when y is equal to 0, so we have 3 x plus 6, 0 will be 360. X will be equal to 360 divided by 3, and so this will be 120. So this will give you x will be 120, y will be 0. Okay, so we have 2 points like this. So it goes to 120, so we need to label your x-axis up to 120. Yeah? So we draw a vertical line here. Okay, draw a vertical line and then draw one horizontal line. So we're going to label this as 20, 40, 60. So we have, maybe it's not long enough, I'll draw a bit longer. So we have 20, 40, 60, 80, 100, 120. 20, 40, 60, 80, 100, 120. So here we have the same thing here. So we label up to 120 here. So you have 20, 2, 4, 6, 8, 10, 12. This will be your x-axis. So 20, 40, 60, 100, 120. So you don't have to worry about the negative parts because we don't have any negative in the equation. So the first point will be 0, 60. 0, 60 will be here. Second point will be 120, 0 will be here. And so you can draw a straight line going to these 2 points. Okay, if you use a ruler, you can draw a nice straight line going through these 2 points. Okay, so this becomes the equation 3x plus 6y equal to 360. The question says less than or equal to. So less than will be the region below the line. So you need to shade the region below the line. Now all this region will satisfy the equation. Okay, so despite here will satisfy the equation 3x plus 6y less than or equal to 360. Okay, so you can do this properly on a graph paper, then you'll get a very nice diagram. Now the last equation will be 800x plus 300y. Okay, 800x plus 300y is more than or equal to 24,000. Okay, let's see how to draw this diagram. Okay, so we have 800x plus 300y is more than or equal to 24,000. Okay, so we draw line with the following equation 800x plus 300y equal to 24,000. Okay, for this kind of question, we forget about the inequality first. So we draw the line given by a straight line like this, and then we say when x is equal to 0, so you have 800, 0 plus 300, y is 24,000. Okay, so y will be equal to 24,000 divided by 300. So this will give you 80. And so from here you got one point, which is x is 0, y is 80. Okay. And when y is 0, what happens? You have 800x plus 300, 0 is 24,000. So x will be equal to 24,000 divided by 800. This will give you 30. So next point will be 30 and 0. Okay, so the axis coordinate is up to 80. So we can mark up to 80 here. So I'll just draw a very simple diagram here. Okay, so you got 80 up to 80 here. So you have 2, 4, 6, 8, 80 here. 60, 40, 20. So this will be your y-axis. And this can be your x-axis. So in the x direction, you have only 30. So we can label this as 20, 4, 6, 8. Okay, 20, 40, 60, 80. So when x is 0, y is 80. You got 1 point here. When y is 0, x will be 30. And 1 more point here. Okay, so we can draw a straight line. Okay, use your ruler to draw a nice straight line. So this straight line will satisfy the equation, straight line equation, but the question says more than. Okay, so you want to shade this region that satisfies this equation. So this region is above the line. Because it is more than, because it's more than, you shade the region above the line. Okay, so this is how we do this question. Let's go through the question very briefly. Okay, just read through one more time. And so you are given area of land 80 hectares, number of workers 360, capital is 24,000. So this becomes the constraint. And you can write the constraint in terms of x and y. Okay, so given like this, so remember that X will be land area. Yeah, so area of land for banana and papaya put together will be less than or equal to 80 hectares. Okay, so once you get each of the equation, then you just need to plot on a graph like this. So plotting on graph is not that difficult. So try this on your own again. Now I'm going to take you all to question exercise 7.2. Okay, exercise 7.2. Question number one. And let's look at question number one. 7.2. Okay, so we will do one or two questions from here just to illustrate the application of linear programming, how to solve problems involving linear programming. Just take a look at this question first. Okay, so in this question, you are told, read the question very carefully, because this is a very long question. Don't rush into reading. Because during exam, you're under stress, you won't read very fast, you may skip some very important information. Okay, imagine that during exam, okay, in your exam hall, imagine that you are the only person there. You lock your mind. Imagine you're the only person in the entire hall. It's between you and the exam question paper. Okay, the question papers in front of you, just focus on that. Don't think of anything else. Okay, so just take a look at a long question like this. Question says, an institution offers two business courses, namely management and finance courses. Okay. Now, in the exam, when you read like this, it's always good to underline as you read. Okay. Institution offers two business courses, underline two business courses. Okay, what are the courses? Management and finance. The number of students in management course is X. So X becomes the number of students in management course. The number of students in the finance course is Y. And then we know X is for management. Okay. And then Y is for finance. So you can relate the two. So when you read, you can just underline important points. The enrollment of this student is based on the following constraint. The total number of students in management and finance does not exceed. So remember, does not means less than or equal. Okay. The number of students in the finance course does not exceed 4 times the number of students in the management course. Okay, so does not exceed means less than or equal. The number of finance students must exceed. Exceed means more than, must exceed the number of management course at least by 10 people. Okay, so I'll show you in a short while how to put all this in mathematical form. Okay, the question says part A, other than x more than 0 and xy than 0, write 3 linear inequalities that satisfy all the constraints above. So what are the 3 inequalities that satisfy all the constraints? So in question number 1, so just copy down, and this is SE 7.2. Make it thicker a bit, SE. Okay. In part A, you are asked to write 3 linear inequalities. Remember, X will be the number of students in management course. So the number of students in management course plus the number of students in finance course condition is does not exceed 80 people, is less than 80, less than or equal to 8. It can be 80 people, but it does not exceed. That becomes the first constraint. Now, the second constraint says the number of students in finance course does not exceed 4 times the number of students in management course. So remember, finance is Y. Okay. So number of students doing finance must not exceed, must be less than or equal to 4 times number of students in management course. Okay, so Y less than or equal to 4x. And then in part C, it says, part 3, number of finance student must exceed the number of management. So Y must be more than X. The difference, when you take Y minus X, must be more than or equal to 10. The question says must exceed. Must exceed. So exceed actually means more, but you can put more or less than, more equal to, sorry, more equal to 10. So these are the three equations for part A. And then you are asked to use a scale of 2 cm to 10 students on both axes, construct and label the region R that satisfy all the above conditions. So you're going to plot this. So we are looking at the first one, for example, x plus y less than or equal to 80. We're going to draw a straight line. So we draw line x plus y equal to 80. Okay, so when x equal to 0, y equal to 80, this will give you the first point, which is 0 and 80. So when y is equal to 0, x will be equal to 80. So you'll get one more point, which is 80, 0. Okay, so we try to get all the 2 points for each of the inequality first. And then for the line, for the second condition, for x, so we plot we can write and draw a plot line. So y is equal to 4x. So when x is 0, y is also equal to 0. So we have to use another variable here where x is equal to 10, y be equal to 40, for example. Or you can put 20 and 80 also, and depends on you, is still correct. So for the third condition, y minus x greater than equal to 10. Okay, so we draw line y minus x equal to 10. So when x is 0, y equal to 10. When y is 0, x equal to negative 10. So this will give you x is 0, 10, and x is negative 10, 0. So here you have x is 0, y is 0, x is 10, y is 40. Okay, so we have all these points we can now plot on the graph. So I'll copy the graph paper first. Yeah, copy. SE 7.2. So you're asked to use 2 cm. You're asked to use 2 cm to 10 students on both axes. 2 cm to 10 students on both axes. So we can 2 cm to 10 students. So you have 80 up to 80. Yeah? So you need okay, so imagine this is 2 cm. No, on the graph paper it's actually 1 cm. Sorry. Okay, so the system has already stopped. So I will stop the recording here. Yes, so we'll just continue from here. So I'll just illustrate how to plot this graph, but later you can do this using proper scale. So I just want to show you the points here for 0, 80 and 80, 0 and so on. So here what we do is that on the negative side, we have only negative 10. Okay, so we can draw the graph for 80. For 80, we have, okay, from here you have, so I think you can start from here. 1, 2, 3, 4, 5, 6, 7, 8. And so I can have the axis over here. So this will be the x-axis. This will be the y-axis. Okay, so this will be your y-axis. This will be your x-axis. So I can label this as 10. Each line here will be 10, 20, 30. No, I don't think I will have enough space on the horizontal axis. And so I'm going to change it to, just for illustration purpose, I will change it to 20 over here. So this will be 20, 40, 60, 80, 100. Okay, and then here we have 20, 40, 60, 80, 100. 20, 40, 60, 80, 100. So this will be negative 20, negative 10, negative 20, negative 40. Okay, so we look at the first graph. X plus y less than or equal to 80. So we have 0, 80. The 2 points will be 0, 80 and 80, 0. So you got 0, 80 over here and then 80, 0 over there. Okay, so you can draw one straight line passing through these 2 points using your ruler later. Okay, so we have one straight line passing through these 2 points. Okay, so this is the first straight line, a straight line for this equation. And then later we'll see which part to shade. And we don't shade anything first. So we're plotting this graph. Second will be y equal to 4x. So you got 0, 4, 0, 0 and 10, 40. Yeah? So 0, 0 will be here. 10, 10, 40 will be here. Okay, so you got one straight line passing through these 2 points. Okay. So the last equation will be y minus x is equal to 10. So 0, 10 and 10, 40. So you got 0, 0, 10 is 1 point here. Minus 10, 0, minus 10, 0 will be here. So you got one more line passing through this. Okay, let me draw properly. So what the question is asking you to do is this. Using a scale of 2 cm, okay, I'm not using this scale, but later you all have to do this properly on a graph paper. Using 2 cm to 10 student on both axes, construct and label the region R. So where is the region R? The first equation is x plus y less than or equal to 20. So this equation, this line here is x plus y is equal to 20, equal to 80. So less, when we say less, then it goes below here. It goes down here in this region. Okay. And then for the second graph is y is less than or equal to 4x. Y equal to 4x will be this line. So less than or equal to 4x will be below here. Okay. And then the third line will be y minus x is greater. So greater will be above this line. Okay, so you'll notice that if I shade this region, okay, and then when I shade this region, and I shade above here, the three regions will intersect around here. Okay, so this becomes your region R. So I think I'll use color to illustrate this more clearly. It will be this region. So this region will be R. Okay, so when you want to illustrate, you can do this carefully. Yeah? This will be region R. Now in the part C, in part C, what are you asked to do in part C? By using the graph in part B, find the range for the number of students in finance course if the number of students in management course is 20 people. Find the range. Okay, what is the range? When x is equal to 20, remember the management course. For management, we have x. So when x is equal to 20, okay, so what we do, we'll use the graph here. Okay, so in part C part 1, x is equal to 20. So from the graph, okay, from the graph, what we do, we draw a straight line, x equal to 20 along here. So x equal to 20, this is 20, x equal to 20. So we draw a straight line. So I'm using a different color so you can see more clearly here. So I draw a straight line like this. Okay. Now when I draw a straight line through x equal to 20, okay, this is x equal to 20, you'll notice that it passes through region R. So it passes through between a lower limit and an upper limit. This becomes the range for y. Okay, this becomes a range for y. So the question is asking you, find the range for the number of students in finance, which is y. What is the range for y? So from the graph, the y goes from the value here, the minimum value, this point. Put dotted line here. This is the minimum point. And then up to the maximum point, maybe somewhere here. So it goes from 30 to 60. So we can put here range for y. So y is less than or equal to 60, greater than or equal to 30. Okay, so it's between 30, which is here, 30 and 60. So when you do this carefully on a graph paper, then you'll get more accurate answer. So it's between 30 to 50, 30 to 60. Okay, so that is the answer for C part 1. Now, if you look at question number 2, okay, question number 2, you're asked to find the maximum total of weekly fees that can be collected. Sorry, I forgot to enlarge them. Maximum total of weekly fees that can be collected if the fees per week from the management and finance students are 60 and 70. So this is the fee for management student, 70 is the fee for finance. So total fee that can be collected will be 60 times x plus 70 times y. So that becomes part 2. So total fees, let's call this K, will be equal to 60x plus 70y. Okay, so we're going to find what is the maximum value, of the fee that can be collected. So in order to find the maximum value, we need to let K be any number and then we draw a line. So usually what we do, we take, in order to find the value of K, we just take the number in front of X and Y, we multiply together. So 6 times 7 will give you 42. So we let K will be equal to 4200, 4200. And 60 times 70 will give you 4200. So therefore, 4200x, 4200 will be equal to 60x plus 70y. Okay, 60x plus 70y. So we draw the straight line. So when x is equal to 0, so we have 60, 0 plus 70, y equal to 4200. So from here, y will be equal to 420 divided by 70 will give you 60. So we have one point here, which is 0 and 60. Okay. And then when y equal to 0, okay, substitute inside the equation, 60x plus 70y, 0 will be equal to 4200. So x will be equal to 4200 divided by 60 will give you 70. So this will give you one more point, which is 70, 0. Okay. So using these 2 points, we are going to draw a straight line. 0, 60 and 70, 0. So 0, 60, 70, 0. I'm going to use a straight red color so you can see more clearly. So 0, 60 will be somewhere here. 0, 60, 0, 70, 0 is here. Okay. And then we draw a straight line to these 2 points. Okay. So draw a straight line through these 2 points. And then you're asked to find the maximum. And look at the equation. You're asked to find what is the maximum of total weekly wage. Now, in order to find the maximum wage, what we do, now this, remember that when we draw this line, we are just using a value of K equal to 42,000. So we don't know what is the maximum profit we can get, maximum income. So what we do here, we copy this line. Okay, so in this case, I'm going to copy and paste. I'm going to move this line. So I can move this line. So you'll notice that if I move this line, it's just like when you use a set square. Okay, you put a ruler there, you put your set square, and then you can move the line. Okay, I'm sure you have done this in school. How to move a line parallel to that line. So here I'm just showing you using an iPad, so I can move this line parallel. So this line was originally here. I'm going to move this. Okay, actually I can move this anywhere. I'm going to move it in such a way it touches the maximum region here. Okay, the line was originally here. So if I were to move this way, I think it's not possible to move this way. Let me copy first. Yeah, I've drawn another line in parallel. Now the problem is it snaps into the other line. Now if I were to move this parallel, then I'm going to move this line. you'll notice that if I move it closer, it is going to touch this point first. Okay, so you'll notice if I'm able to use set square to move the line, it will touch this edge first. Okay, so that becomes the maximum point. Now, unfortunately, here the line will be, let me try. So this line is parallel to this line. When I draw, here, something like this. Now you can see. So when I move the line parallel, it's going to touch this point as the maximum point. So the coordinate of this point will be, you can find this from the graph here. Okay, so if you look at the graph carefully, let's see, let me use another color. For this point, the x value here will be roughly around, this will be 10, around 18. X value around 18, y value will be around 67, 62, 64, for example. Okay, so from the graph, we can find the maximum, the optimum point. We call this optimum. It will give you the maximum profit. X will be 18, Y will be 64. So X is 18, Y will be 64. So the maximum fee that can be collected, okay, maximum fee will be equal to 60x. Now X will be 18 plus 70, Y will be 84. Okay, so when you work it out, you will get the value from there. Let me work it out from here. Because earlier when I was trying this, the answer was different, because we were looking at different points, different scale on axis. So this will give you 60 times 80 times 18 plus 70 times 84. This will give you 6,960 ringgit. Okay, so that will be the maximum income. The question asks you to find what is the total maximum total weekly fees that can be collected. And so the fees is given by the equation 60x plus 70y. Okay, so what is the maximum for this? So we need to find x and y value. So we just introduce a variable known as k is equal to 4,200. So k can be actually any value. And so we introduce 4,200 in order to draw a straight line on the graph. And then we move the line in such a way that it touches this region at the highest point. Okay, so at the highest point, x is 18, y is 64. So when you substitute inside here, you can find what is the maximum fee. Okay, so this kind of questions are quite easy to do because you just need to know how to draw the graph, how to identify the constraints, and then you need to know how to plot the graph and then find what is the objective function here. So the objective function here will be the total weekly fees. So in order to find the maximum, we draw a line and then we move the line in such a way it touches the maximum point. Okay. So there are many more questions. You can try this on your own, like 7.2 question number 2, 3, and so on, and also in other exercises. And if you all have any difficulty, as I mentioned earlier, you can contact me by email. Then I will show you one-to-one. I will show you how to solve each of the problems. So I've shown you just example of how to solve problems involving linear programming. Okay, so this will bring us to the end of the free online advanced tuition. Okay, as I mentioned earlier, right, in the beginning, the reason why I'm giving this tuition free so that I can reach out to as many students as possible far away from KL, where you don't have really good advanced teachers. So my intention is that the video, the recording here will give you an alternative for you to learn advanced by solving problems taken from the textbook. Now, if you need any help, just contact me. I'll give you my email address at the bottom here. You can copy down. My email address will be mmr5417 at yahoo.com. Okay, so I'm using this email address most of the time. So if you have any difficulty, just contact me by email. Then I will set up a session one-to-one if you have any difficulty in solving advanced problems, or if you need any guidance how to prepare for your exam. Okay. So thank you very much for following my class all this while. I hope this online administration class has been beneficial for all of you all this while. And thank you so much. So I'll stop the recording here.